Write a formula for the general term of the sequence. Well, what that means is I need to identify some form of a pattern because I'm looking for the nth term, how I could find that. Well, looking at these, I go from 16 to 4 to 1 to 1/4. So I'm dividing by 4 at every step. That means I'm going to have a 1/4 to some power of n because I'm decreasing as I go along. And so that means I'm multiplying by an additional 1/4 at each stage in order, because multiplying by 1/4 is the same as dividing by 4. But I need to have a 16 in here somewhere. So maybe I'll multiply by 16 because that'll mean that's what I start with is 16. But then what I need to figure out is, so this would be when n is 1. Well, I want the 16. I don't want 16 times 1/4 when n is 1. But if the exponent were 0, then the 16 would be my first term. So to make an exponent of 0 for my first term, I'd have to have 1 less than n because n starts with 1. So let's see, this would, when n is 1 for my first term, I'd have 1 minus 1 is 0. So that means I'm not multiplying by the 1/4 yet, and I just have the 16. So that works. When n is 2, 2 minus 1 is 1. So that means I'd have the 16 times the 1/4, which is 4. And as I progress, if n were 3, 3 minus 1 is 2. So I'd have 1/4 squared, which is 1/16. Multiplying by the 16, they do cancel. In other words, at this point, I am dividing by an additional power of 4 all the way along, but I do fit the n equals 1, n equals 2, n equals 3, etc. pattern. So that means my nth term would be this quantity. And then I was also asked in this problem to find the 12th term. So I want a, instead of a sub n, I want a sub 12. So that means n equals 12. So I'd have 16, and I'd have 1/4 to the 12 minus 1. So that's going to be 16 times 1/4 to the 11th power. So I need to evaluate out the 11th power. And so I have 16 over 4 to the 11th is another way to look at 1/4 to the 11th. And after I cancel the 16, that will leave me 1 over, and I'll have 262,144.